Hello friends, welcome to Study by Technology, and in our today's session we will discuss about motion. In this chapter we are going to discuss some details about what is rest, what is motion. We will further discuss about scalar and vector quantity. We will discuss about different types of motions which are present in your course. We will also discuss about how you can use a pendulum and what are the various terms related to a pendulum. And at last, we will discuss some details about force and weight. Okay, so now let's go ahead and start our session for today. First point is about rest and motion. Now, when a body is said to be at rest and when it is considered to be in motion. Now, let's say we have something in our room. We are sitting in a room and we have a lot of things are there. So let's consider any one of that. Now, check like if its position is changing with respect to the surroundings in the room or not. Just for an example, you have a table in your room and you are sitting in your room over there, right? So do you observe, is there any change in the respective position of yours with respect to the table? If there is no change in the position with the passage of time, in that case, both table and yourself are supposed to be at rest. Okay? But if the position of the body, this table with respect to you or your position with respect to table is changing with the passage of time, then it means that either of you are in state of motion. Okay. Now this rest and motion are basically two relative terms. Like let's say you are traveling by your car, right? And a person standing outside the car will look at you and he will confirm that okay, yes, you are in a state of motion, right? But for a fellow passenger which is who is sitting with you in the car, like for you and for him, your positions are not at all changing with respect to each other, right? In that case, with respect to a fellow passenger, you are at rest because the positions are not changing. But a person standing outside the car means like for the person standing outside, with respect to him, the position of your fellow passenger and yours itself are changing with respect to him. So he can say that yes, you people are in state of motion. Okay. So this is something called as rest and motion. Now if we move ahead and we try to figure out like scalar and vector quantity. So you know about a lot of physical quantities like we have temperature, like we have mass, like we have distance and so on. So the physical quantities that require only the magnitude are called as a scalar quantity. Let's say mass of a body. So mass of a body do not need any specific direction. The mass of body is a quantity of matter contained in a body. It do not need any kind of direction or any special definition. So that's the reason it is called as a scalar quantity. Now, a physical quantity that needs both magnitude and direction for its complete description is called vector quantity. Right? Vector quantity. Now, let's say if we take an example from this, we have, let's take an example over here. Mm, yeah, this line is there and it is moving towards east direction, right? This is means like it is some body is there which is moving in each direction, right? In a similar manner, like you can say we have a line like this, and some body is moving, and that body is moving in north direction, right? We can say that this particular body is moving, let's say, 60 degrees to the east, 60 degree to east, right? So this is how we can express a direction. Like let's say this is your home and this is your school, right? So you can say that if you join this your school with a straight line from home, you can say that your school lies in the northeast direction of your home, right? So this is something like which direction, which requires a direction, right? So these type of quantities where you need to represent them with the help of a direction, that kind of physical quantities are called as vector quantities. Some examples for the same are your displacement, your velocity, and so on. Moving further, there is something called as distance and displacement. So before we go ahead in so much of details, let me take out a very simple example over here. All right. Now let's say here is your home. Okay. Here is your school. Here is your some cafe, and here is some playground. Okay. Now from your school, once you leave from the school, just in the morning, you come from home to your school like this. After school, you go to some cafe over here, something like this. After taking a short snack from there, you straight head towards your playground, and after playing from there, you just move back to your home. Right? This is what the curve you are showing over here. This and length of this entire curve, that is from H to S, then S to C, then C to P, and P to H. Right? The addition, if you add all those distances, what you will get? You will get distance. Okay, this is what your distance means, or the length of the actual path traveled by a body is called distance. Right? Now, if we take out some another example, let's say, yeah, here is your home, here is your school, and here is your, let's say, some coaching center. Right? Now, what you will do is like in the morning you get up and just come to your school from here, like this. After this school, you just head towards your coaching center. Right? Now, let's say you are staying here only. What happens? The total distance between H to S and S to C is considered to be the distance. Now, the shortest distance between your initial position and the final position is called as displacement. Okay? That means if you take a straight line and join this A H with C, then that is the shortest distance. But this shortest distance is called as displacement. Always remember that the shortest distance between the initial position and the final position is called as displacement. Right? Now, let's take another example. Or let's head toward the previous example only. Here, you started your journey from home, you come to your school, after that you come to the cafe, and after that you come to the playground, and then at night you come back to your home. So now your home is your initial position as well as your final position as well, right? Now there is no difference. That is like the final position is same as the initial position. In this case, the final position minus initial position will be 0, right? There is no distance between them. So in that case, it doesn't matter how much distance you have covered so far in the whole day. The total displacement of a round trip of a journey will always be 0. Okay. So now let's say some body is rotating circularly, circular motion if it is there. So always it may be possible that it's covering a lot of distance, but actual displacement of the body will be 0. Right? I hope this point is clear to you, and that's the main difference between your distance and displacement. So distance is a scalar quantity, but displacement is a vector quantity. And what you can see like this line, right, and this line, these are all the vector lines actually. Fine. Now let's go back. So as you can see the definition here, that the actual length of the path covered by the moving body in a certain interval of time is called as distance traveled by the body, and the shortest distance covered by a covered in a particular direction by a body while moving from one point to another is called displacement. Right. Now again you can see the difference between distance and displacement. As I've already explained to you that distance is a scalar quantity, however displacement is a vector quantity. Now distance is always positive. Of course, like even if you move a certain inches, that is nothing but just a displacement. And sorry, distance. But distance can be positive or negative, right? It can be both positive or negative. Let's take the example from here. If you remember, like we have already studied that point in our class that about the number line, right? I'm sure you know very well about the number line. What is this number line over here? Number line is actually it's like let's say this one, and right, we have this line here. We have 0, we have 1, we have 2 over here, and we have -1, we have -2 over here, right? So this side is positive and this side is negative, right? Now what happens, let's say on one fine day, let's say your home is at your house is at this position, you go to your coaching center and you find that this is closed for today. Now you come back and on the way you find your home, but instead of going into the home you just reach to some cafe coffee day, right? CCD, right? You sit it for some time to have some coffee and like that. So now in that case, what will happen? This will be the negative direction, right? This will be the negative direction. Now negative direction is something like you can say the displacement is negative. So you can say that this displacement can be positive or can be negative, but distance will always be positive, right? Now let's go back. Okay. So distance traveled can never be 0, but the displacement can be 0. That you know very well. Again, like if you move even a single inch, then this is something the distance that you might have covered. But if you again come back after covering a lot of distance, even hundreds of kilometers, after covering hundreds of kilometers, and if you come back to your home or to your initial position, the displacement will be considered as 0, right? Now the last point, that the distance is always greater than or equal to the displacement. That I'm sure so far you might have understood that. and it is something like, let's say, even if you move a single inch or something, then what will happen? There is a distance. But distance, like let's take an example. Let me show you how we can realize this concept. Let's say this is your initial position, right? And you travel from here, and this is your final position. Fine. So this is your initial position and this is your final position. That too you are moving on a straight line. That means like the difference between final position and initial position is actually equal to the distance. So in that case, distance is equal to displacement, right? Now let's say the distance between 2 points is x. Fine. Now after some time you just return from f to I. Fine. So how much the distance is? Distance traveled by you is 2x, but the displacement is 0. So of course 2x is greater than 0. That simply means that distance is always greater than or equal to the displacement. Right? Now moving ahead, there is a concept of speed and velocity. Speed of a moving body is defined as the distance traveled by the body per unit of your time. Okay, in 1 hour how much distance you can cover, that is the speed. In 1 second how many meters of a particular distance you can cover, that is again a speed, right? Now if we talk about the displacement, like how much displacement you have covered in 1 hour, then that is called a velocity. So remember that the rate of change of distance is called as a speed and rate of change of displacement is called as velocity. Now again, all the properties of the displacement and all the properties of velocity will be almost same. Like you can say that again the speed is a scalar quantity, but the velocity is a vector quantity. Speed can never be negative. Why? Because distance also can never be negative. But the velocity can be negative as the displacement may or may not be negative as well. Right? Now, moving ahead, it's something about the motions. So first type of motion over here is called uniform motion. Uniform motion is one when a body covers equal distance in equal interval of time along a straight line. Right? Similarly, let's say a body covers 1 kilometer in 1 hour. Then on second hour also it covers the same 1 kilometer. In third hour again it covers the same 1 kilometer. So that's something called as uniform motion. Like if you have non-uniform motion, that is when a body covers unequal distances in equal intervals of time along a straight line, then that is called as non-uniform acceleration. Right. Now this one about this non-uniform motion. Let's say a body covers 1 meter in 10 seconds, and another 10 seconds it covers 20 meters, in another 10 seconds it covers 40 meter, and so on. So if this kind of motion is there, then that is called as non-uniform motion. Moving ahead, now about types of motion. So there is something called as translatory motion, that is a motion in which every part on a moving body moves the same distance in same interval of time. That means like if you are moving, it doesn't mean that your hand is moving in some another direction, your head is moving to some another direction, your legs are moving to some another. No. The entire body structure will move in a single particular direction, and that type of motion is called as translatory motion. Now, these translatory motions can be further classified into rectilinear motion. That is, in this, the moving body moves along a straight line, and thus this type of motion is called as rectilinear motion. Then we have curvilinear motion. If the motion of a body is along a curved path, its motion is called as curvilinear motion. So you can see in this animation that we have a basketball player which is throwing up or dribbling the ball first and then trying to basket that ball. It is throwing that ball upward in such a way that it travels in a circulatory motion or curvilinear motion. Moving ahead, that's something called as a rotatory motion. So like when a body moves about a fixed axis or a fixed point without changing its position, the body is said to have a rotatory motion. You can see that we have in this cycle, the central part of the first wheel, right? This is the axis, and all the points of the or lying on the tire are moving with the same speed around this particular set of axes. Okay. Oscillatory motion is a motion in which a body moves to and fro or back and forth about its main position is called oscillatory motion. We will discuss this kind of motion in some more details while we will be studying about the pendulum. Okay, so you can see here that every to and fro that is moving from one direction to another direction, then that type of motion is called as oscillatory motion. Then we have something called as vibratory motion. It's a motion in which a part of body moves to and fro in a definite style while rest of the body always remain fixed, and that's called as vibratory motion. On extreme left you might see there is a U-shaped object that is called as tuning fork. Okay, it is mainly used by ENT doctors, and whenever you vibrate it, it will generate a characteristic sound. Similarly, on the right figure, you can see that we have a wire set of wire that is basically a structure of a guitar. So whenever you hit that wire, it will vibrate accordingly and generate different sounds. Then we have a periodic motion. That is any motion that repeats itself at a regular intervals of time is called a periodic motion. I'm sure you might think of like a weekday test, or sorry, weekend test that is supposed to be there on Sunday. So every Sunday we have a test. That means we have a periodic motion over there. I mean, let's take it a little bit serious now. You can see that Earth is moving around the sun, and it gets light. Sometimes it gets light being very near to the sun, or sometimes it's quite away from the sun. Right. So during summer season, which actually starts from 1st of April and like that. Similarly, we have winter season. So that always happen on a particular set of time only. Why? Because these are the periodic set of motions. The non-periodic motion, the motion which does not repeat itself after a fixed interval of time, is called as non-periodic motion. So you can see here that these balls, the artist is using this ball, but any ball can come after first one, previous one on that. Moving ahead, now we have examples of multiple motions, or complex or multiple motion. That is a motion which is a combination of two or different types of motion is called as multiple motion. You can see here that we have a bicycle. Some person is riding a cycle. Now he is. It is an example of multiple motion because, like car others on wheels, are actually there in rotatory motion, right? And but the cycle is actually traveling, ahead of these cases. So this cyclist is moving ahead in rectilinear motion, but the wheels are moving in a curvilinear motion. So that kind of motions are called as complex or multiple motions. Fine. Now we have a rolling motion. That is a motion in which there is simultaneous occurrence of both rotational and translational motion. In previous setup, you might have seen that we have setting up for this one rotatory motion and linear motion, and here we are talking about curvilinear motion and linear motion. Fine. So you can see that the planet Earth, which is revolving around the sun, is actually under these two set of motions. Now let's discuss about the pendulum. Pendulum. You can see here a pendulum which is actually oscillating. This is actually the product part showing you the oscillatory motion here, right? So there are a couple of terms which are related to the pendulum. First one is the point of suspension. Point of suspension is the one through which your pendulum hangs, right, or which provides support to the pendulum. Then point of oscillation. Point of oscillation is basically the point where center of gravity acts. That is called as point of oscillation. Now length of pendulum is actually the length of the wire plus length of radius of the bob actually, right? You can see that like length of the pendulum is the measurement from your point of suspension to the point of oscillation. Now we have mean position. Mean position is something like when a pendulum is at rest. So yes, of course, the bob will also at rest. So that kind of motion, that kind of position is called as mean position. Now we have extreme position. You can see that this bob is touch just now. It will start backward direction. That means the point where the maximum distance between the your this one position of oscillation, point of oscillation, to the point from where this pendulum turns back. Okay. Now we have amplitude. The amplitude is something like the maximum, displacement by a pendulum, or maximum distance away from the given mean position. Then that is called as your amplitude. Now time period. Now time period is something like how much time will this pendulum take to complete one revolution. All right, that is something called as time period. Now, if we have this, can't we find out like what is the frequency of this pendulum? Frequency is actually the reverse of time period. Fine. So let's say you have rated this time period as 10. So the frequency will be 1 upon 10. Fine. Now, these are the set of definitions. Under this, like you can see a point of suspension, which is actually a fixed point, and on a rigid support from the pendulum, from where the pendulum is suspended. Point of oscillation, that is the center of gravity of the pendulum. Length of pendulum is the distance between the point of suspension and the point of oscillation. Mean position, that is the point of the bob when the freely suspended pendulum is at rest. Now extreme positions is the position of the bob at the maximum distance from the each side of the mean position. That is called as your extreme position. Now one oscillation, that is one complete to and fro movement of a pendulum about its mean position, is called oscillation. In case of amplitude, the maximum displacement from its position is called as amplitude. Okay. Now we have time period. This time period is basically the time taken by a pendulum to complete one oscillation. And now further we have frequency. These are the number of vibrations of oscillation. One oscillation stands for 1, 2, and 4 movement. Okay. So made by pendulum is 1 second. That means that is a number of vibrations or oscillations made by pendulum is always 1 year. Fine. Now something about force. Force is nothing but just a physical cause which changes either the size, shape, sets a body into motion, or brings the moving body into challenge. Right? This called as force. Now it's something about weight. The force with which the earth attracts a body is called weight. Okay. So weight completely depends on the mass of the body and acceleration due to gravity. Fine. Now, if you have mass of a body and if you have acceleration due to gravity, you just go ahead and multiply them and you will get your answer. Right? This is something about your weight. Now, this is all done for class 7. If you have any more doubt, any more query, any questions, please feel free to let me know. Till then, have a nice time ahead and take a very good care of yourself. Bye bye.